Your computer science degree taught you binary trees, big O notation, and how to implement a linked list from scratch. None of that saved you the first time production went down at 2 in the morning and you had no idea what to do next. Everything that actually matters in a real developer job, nobody taught you. This video is what your degree skipped. Fair warning, this is not theory. This is the stuff learned through pain, embarrassment, and late-night debugging sessions. If any of this hits close to home, that means you needed to hear it. Heartbleed didn't start with some elaborate hack or a genius attacker. It started with a single missing length check in OpenSSL, a tiny oversight buried in a codebase trusted by 2/3 of the internet. One unchecked field, and suddenly anyone could send a malformed heartbeat request and siphon off 64 kilobytes of memory from any server running the vulnerable version. Private keys, passwords, confidential data were all up for grabs. All because nobody stopped to ask, what if this input is not what I expect? For years, that bug sat undetected, quietly leaking secrets from banks, hospitals, and governments. When the world finally noticed in April 2014, it was already too late. A security researcher summed it up. If every function that receives external data performed a simple length verification, Heartbleed would never have existed. This is what correctness in the classroom misses. Real systems do not fail because the code is wrong on paper. They fail because nobody planned for the ugly, unpredictable, real-world inputs. Defensive programming is not optional. It is the only thing standing between a harmless typo and a global disaster. At GitLab, one engineer sat in front of a terminal, fighting a database outage that just wouldn't die. It was late, the pressure was real, and every second the site stayed down meant angry customers and lost trust. He thought he was deleting junk data from a replica. Instead, a single rmrf command on the primary server wiped out 300 gigabytes of live production data, gone in under a minute. The backups were broken for weeks, but nobody noticed until it was too late. 18 hours of outage followed. 5,000 projects, comments, and new user accounts all erased. There was no confirmation prompt, no safety wrapper, just raw command line power with zero guardrails. The only thing between a typo and disaster was hope. This wasn't a bug in the code. It was a missing layer of operational defense, a script, a prompt, a checklist, anything to catch the human before the system broke. In the real world, reliability isn't just about the code running right. It's about making sure the right thing can't turn into the worst thing at 2 a.m. because someone trusted themselves a little too much. Knight Capital's meltdown wasn't caused by a clever hack or a tricky bug. It was old code, ghost code, that came roaring back to life. Picture this: 8 production servers, all supposed to get a new trading module. 7 got the update. 1 did not. That single outdated server still had a dormant flag, a relic from an old algorithm called PowerPeg. When a routine deployment reused that flag, the sleeping code woke up. Suddenly, millions of bogus trades flooded the market. Orders nobody intended, triggered by a logic path nobody remembered. In 45 minutes, Knight Capital lost $440 million. Engineers on the trading floor watched helplessly as the system spun out of control. By the time they found the source and killed the process, the damage was done. The lesson: in the real world, legacy code is not just clutter. It is a live wire waiting for one careless update to turn a forgotten branch into a financial disaster. Taming legacy code is not about heroics. It is about building yourself a safety net before you touch a single line. Start with characterization tests. Do not trust what the code is supposed to do. Capture what it actually does right now. Bugs and all. That is your insurance. Next, fire up static analysis tools. CodeQL is a heavy hitter here. With one query, you can hunt down every place a risky function is called, or spot dead code waiting to bite you. Then comes the real-world move. Never swap out old logic in one go. Use feature flags. Wrap your changes behind a toggle and send just 5% of traffic through the new code. If something breaks, flip the switch and stop the rollout instantly. No all-nighter, no disaster. Canary deployments and kill switches are not just buzzwords. They are how you avoid becoming the next Night Capital headline. The difference between a theory-perfect refactor and a safe one is this. In the real world, you need an escape hatch before you need a victory lap. Nothing wrecks your confidence faster than fumbling through a terminal while everyone's waiting for you to bring the service pack. Picture a junior SRE sweating bullets, staring at a blank shell prompt while the outage clock keeps ticking. The run book skips a step. Logs are buried 3 directories deep, and nobody taught them how to chain a greep with a tail or SSH into a flaky box. A senior engineer once joked that you can spot the rookies by how long it takes them to find the right log file. But the joke wears thin when you see the numbers. Teams that drill terminal basics, file system navigation, log slicing, and command chaining clock a mean time to recovery of 27 minutes. The ones who wing it clock 73 minutes on average. One fintech shop lost 2 hours rebuilding Redis from scratch because nobody knew the flush and restart incantation. Terminal fluency is not a resume bullet. It is the difference between a blip and a career-defining disaster. Git isn't just a place to stash your code, it's the language your team uses to keep chaos in check. Every vague commit message, every push straight to main is a loaded gun pointed at your own foot. Shopify's engineering leads dug through their incident logs and found that almost a quarter of production failures came from unreviewed pushes. Someone had skipped the pull request, thinking they were saving time. Atlassian's dashboard tells the other half of the story. Teams that keep at least 80% of changes peer-reviewed see their recovery times cut in half. That's not a suggestion. It's a survival rule. Write clear commit messages. Name your branches like you expect someone else to wake up at 2 a.m. and read them. Describe your pull requests like you're documenting a bomb defusal manual. Git hygiene isn't about looking good for a code review. It's about making sure nobody, including you, is ever left guessing what happened when everything goes sideways. In the real world, code does not care about your degree. It cares if it survives the night. Software lives or dies by how you handle chaos, not how you pass a test. Stay sharp.